So a while back, I did a video on how to add HA data to your RGB broadband data. And we did that using continuum subtraction, right? Generally, that process is reserved for those of you that shoot in mono. But in that video, I showed you how those of us that are shooting with a color camera can split out our channels into monochrome and do the same thing. We did that using continuum subtraction, and it worked very well for the galaxies. This is an update to that video. It's not only a little bit of a new workflow as far as how I go about doing it, but there's also a new Python script in the new version of Siril that builds this continuum subtraction for us without any pixel math involved. If we want to go that route, there is an option where you can still use pixel math if you want full control over everything. But we'll go over both options in this video. It's a really cool script, saves you a little bit of time. Like I said, you don't have to mess with any of the pixel math stuff to get it done. So let's take a look at it. My name is Rich, and you're watching Deep Space Astro. So let's start with the data that I'm working with today. I shot the Andromeda Galaxy over 2 nights. The first night, I shot it using my Optolong L Pro filter, so just a light pollution filter. And then on the second night, I shot the same object, but this time I used my IDAS MBZ2 dual narrowband filters, which isolates the HA emission line that we're after. So again, for the first night, this one right here, I stacked the data using Siril's OSC pre-processing script, and the HA data behind the narrowband filter, which again is over here. I created this stack by using Siril's script extract HA. So that's what we're working with today, are these two stacks. Again, one behind the L Pro, the other one behind the dual narrowband filter. So what I want to do first is I'm going to create 2 new additional folders. I'm going to call one working, and then I'm going to call the other one process. And you don't necessarily need to do this. It just helps keep things organized as we go through this workflow. So I'm going to come over and grab my L Pro stack, and I'm just going to make a copy and put that into my working directory. And then the same thing, I'm going to come over into my HA stack and make a copy of that, and also put that one into my working directory. All right, so we're going to come over into Siril, and in preparation for running the continuum subtraction Python script, we're going to go ahead and get that installed. So come up to your burger menu, click on Get Scripts, and down the bottom here, you're just going to scroll down towards the bottom until you see continuum subtraction, this one right here, and put a tick mark over to the right and click Apply. And we're going to set our working directory to the directory that I named working. So this one right here. And then I'm going to open up my L Pro stack. So this one up top, you can see HA is in the name of the HA stack. So we're going to double click that one to open it. We're in linear. We can go into auto stretch just so we can get a view of what the data looks like. And the first thing we want to do, because this process requires all monochrome images, we're going to split the image out into their individual RGB files. So image processing, channel extraction, split channels, and you can name these whatever you want, but I'm just going to go with RGB, and then click Apply. It'll show you in the console when it's done. It's really quick. Click Close, and then if we jump back over into our working directory, we can see the 3 new files that it created. Again, back over into Siril, we're going to change the working directory again. We're going to come out of our working directory, and we're going to go into process because we need to register and align these images, and I don't want all of the additional files in my working directory that are going to be created when we go through this. So set the process directory as our working directory. We're going to come over into our conversion tab, hit the plus button. We're going to back up 1 level into our working directory, and we want to select our red, green, blue, and our HA, but we're not going to select our initial L Pro stack. So just the monochrome images that we now have. Click Add. They're now added into the conversion tab, and we need to give our sequence a name. You can call it whatever you want, but I'm just going to go with channels and click Convert. Once the conversion is done, we're going to jump over to registration, global star alignment with all the default settings. Our prefix is R_, which is fine, and click Go Register. At this point, we're going to go back over into our working directory. And again, just to keep things clean, we no longer need any of these files that we were just working with because we're going to replace them with our new registered files that we just created. So I'm going to delete all 5 of those. I'm going to come up into my process directory. I'm going to look for my 4 files that are prefixed with R_. These are our registered images. So I'm going to take those, I'm going to cut them out of the process and paste them into the working directory. Now, again, you don't have to do this part as well, but I like to rename these just so I know what they are at a glance. So if I go back into my process directory and open up the conversion.txt file, you can see it says channels underscore. Channels is the name that we gave the sequence when we did the conversion. So if you didn't name yours channels, this part of the file name will be whatever your sequence name is. So just double click it to open it up, and we're going to use this as a reference so we can rename our files. So we're going to go back up into our working directory here, and we're just going to reference each of these file names. So we're just looking for the numbers right now. So this one with the number 1 in it, if we come over here, we can see it initially was our blue channel. So I'm just going to rename that to blue. Same thing, 2, looking at our conversion file, 2 is green. So we'll rename that to green. 3 is red. And then the last one is our HA. So I'm just going to call that HA. We're done with the conversion file, so we can close that. So now these are the 4 files, all monochrome, that we need to do our continuum subtraction and build our composite at the end. So we're going to go back over into Siril, and as I mentioned before, if you're doing this in mono, you already have these mono images, so this is the point in the video where you would start. You don't need to do any of the previous stuff that we just went through, because that was all for those of us who are running one-shot color cameras. So the first thing we want to do is, again, change our working directory back to our working directory and click open, and we want to open up our HA file. And we're going to come up into scripts, Python scripts, and continuum subtraction. Pretty simple to use. There's only really a couple options you need to be concerned with, but let's go over what we're looking at here. The first line where it says narrowband image, you can see it's showing our ha.fit file, which is the image that we just opened up. The continuum image is going to be our red channel. So we're going to click browse, and we're going to select our red channel. Subtraction factor, I recommend just leaving it on auto and let it do its thing. It'll figure out the best subtraction factor for you based on the data in the 2 images. Show optimization plot, it'll actually show us the curve that it created and determine what that best subtraction factor should be. And then we have our output type. There's 2 to choose from. The first one, selected by default, is the continuum subtracted narrowband. This will give you the pure HA signal file to save, and then you can take that and build your composite using pixel math. We'll circle back and go over this later, but for now, we're going to run through using the enhanced continuum. And what the enhanced continuum will do for you is not only just create that pure HA image, but it will use it in conjunction with your red channel to build you a new image to use as your red channel. So no pixel math involved at all. Also, with this option selected, we have an enhancement factor. For now, we'll leave it at 1 because I just want to show you how it works. So at this point, all we would need to do is click apply. It's not recommended. It's not the optimal way to do that, but I will show you just by clicking apply. And if we look down here in the console, you can see just what I was talking about. There is no selection made. It's using the entire image to do all the math that it needs to do, and it's probably not optimum. Now, you may get a decent result out of it. It may work well, but we're going to go with the recommendation once this is done and use a selection instead. So there's our plot that I was talking about on the left-hand side, showing our average absolute deviation and the scale factor on the bottom, and the lowest point of the curve. It's determined the optimal scale to be 0.2871. And if you look in the script, that's what it set the subtraction factor to. So we're going to close the plot. I'm going to untick it so it doesn't show back up again for us next time. I'm going to delete the subtraction factor and just put auto back in. And we're going to do 2 more things here. The first one is we're going to draw the selection as recommended. So using your left mouse button, just like if you're getting ready to do a crop, just draw a selection around, a pretty large selection around the object of interest. So something like that. And I am going to bump the enhancement factor up from 1 to 3. Now, this is something that you can play with. If you go too high, you'll start seeing as you do your stretching that the HA regions that we're trying to enhance or trying to pull up will be really start looking oversaturated. So it's something that you'll play with, and you can kind of get an idea what it's going to be by looking at the image. So what we have on the screen right now is at an enhancement factor of 1 from our previous run. So just kind of watch around the dust lanes here, specifically right in here. There's quite a bit of the little HA jewels that I know are going to pop up with this. The other thing that I want to point out is you can see in the top right corner, it says result.fit. So this is not our HA image that we initially loaded, but it's still showing as what's going to be used in the script itself. So I point that out because you may think before I do another run with the script that I should open up my HA image again. You don't have to. the script is showing you right here that it is going to be using the HA image regardless of what you're seeing. So again, with our selection around Andromeda, my enhancement factor set at 3, my subtraction factor put back to auto, going to click apply. And you can see it's a lot faster this time around with the selection versus needing to look at the entire image to try to figure things out for us. So hopefully you can see it. The enhancement factor of 3 around the dust rings where I know those HA regions exist, they've popped already a lot more even in this monochrome image. So I can actually see more detail in them. Again, something you can play with. You can go up higher. Just keep in mind, if you're going to do another run, you're going to want to delete your subtraction factor and put it back to auto again. So I'm going to be good with that. So we're going to close the script. And like I mentioned before, it shows result.fit, but if we came back into our working directory, there is no result.fit here. So the image exists only in serial right now. We need to save it. In a future version, it may save it automatically for you, or there may actually be a button in the script to do that save. So they may add the ability to save right from within the script in a future release. So for now, we need to save it ourselves. So can't use the save button because it's grayed out. So we're going to come over and use the save current image button. And because we did an enhanced continuum, I'm just going to name it EC for enhanced continuum. Call it whatever you like. Click save, 32-bit. We're going to get a warning because we're in an auto stretch view that the image is still linear. We know that, so we're going to say save anyways. That's fine. And now we just need to build our composite. So we're going to come up in the image processing, composition, RGB composition, close the current image. Yes, that's fine. And for our red channel, we're going to select our enhanced continuum image. For the green channel, we're just going to put the original green back in. For the blue channel, we're going to put in the blue image. Close it, and the image looks the way that it does because it's linked currently. So if we come down and we unlink our auto stretch, then we get a little bit tamer view of everything. But we need to fix that, right? So at this point, that's our composite. You can see the little HA jewels around the galaxy, but we need to process it just like anything else. So we'll go through that. So first thing we're going to do is a crop to get the stacking artifacts out. And in this case, the artifacts are because we combined the HA in with the RGB from different nights. So there was a slight bit of rotation difference. Right click, crop, and then crop. And then I'm going to do a background extraction. So you can do your background extraction however you like. For the video, and because this is the new version, we'll use the Graxpert AI script and set it to background extraction. I'm going to leave my smoothing at 0.5. That's fine. And then just click apply. Background extraction is complete. We'll hit close. Now that the background extraction is completed, our image has got that nice little teal glow to it. So if we go back down to our auto stretch mode and relink that stretch, now things are back to the way that we expected them to look. Next thing I want to do is color calibrate. Before we do that, we have to plate solve. So tools, astrometry, image plate solver, and I'm just going to click OK. Now we can color calibrate it. So we're going to come up in the image processing, color calibration. I'm going to use SPCC. I got my sensor set correctly, my L Pro, and just click OK. Get rid of our plots, click on close. So now we're fully color calibrated. And at this point, and I should have done this right after I did the composition, is I'm going to save this because as you can see, it's telling me it's an unsaved result. So we'll click on the save as button here, and I'm just going to call it M31 comp. Again, you can name it whatever you want. Save, 32-bit, save anyways. Next step, we're going to remove the stars. So image processing, StarNet star removal, pre-stretch linear, generate star mask, and then click execute. Okay, so StarNet's completed and we're looking at our starless image. So now we can begin stretching. So I'm going to come out of auto stretch mode into linear, and you can stretch this data however you like, whichever one of the tools that you use, whether it's GHS or the histogram transformation, however you go about it, that's fine. But in the interest of time and just to show one of the new scripts that are also included in Serial, I'm just going to use the statistical stretch script. So we'll come up to scripts, Python scripts, statistical stretch, and we're color calibrated. So I want to link it. I'm going to normalize it, tell it to give it a little bit of a curves boost, and we'll just take that up to somewhere around 0.15 and click apply. Close when it's done. And at this point, if you see a little bit of a green cast in your background, you can come up to image processing and do a remove green noise. Just leave the default average neutral protection method, hit apply, and yeah, it cleaned up that green noise in the background. So before moving any further, always check your visualization sliders down here on the bottom. The top one should always be all the way over to the right. and the bottom one should be all the way over to the left. Sometimes they jump around as you're going through some processes. I've even seen it when I've ran statistical stretch, and this top slider specifically would be halfway over and everything looks all blown out and you have no idea what's going on. Always check your sliders. It's as simple as moving it back over and everything looks as expected. So we got our first initial stretch done now. We moved our green noise, so I'm going to come up into stretches and do my curves transformation, because even though that's a decent stretch, it looks a little light to me. And I'm just going to pull down my darks a little bit and bring up the lights. Just the infamous little slight S curve, right? Hit apply, and you can do it however many more times that you feel necessary. Get it to look the way that you want it to look, and then click close when you're happy. We're going to call that good. Come over, click my save button, because the next step now is to add the stars back in. So image processing, star recomposition, yes to close the current image, and under background stretch, we're going to load our starless. And under star stretch, we're going to load our star mask. Most of the time when I'm bringing stars back in, I like to click the advanced button and change my color stretch model from independent to either human weighted or even. It tends to help maintain the colors in the stars, and just start stretching your stars in. It's all about preference, however you like them. I'll just bump it over a little bit more. I like that. We'll call that good. Hit apply, hit close. And I'm going to use another new script within Siril to sharpen both the stars and the Andromeda Galaxy. So scripts, Python scripts, Cosmic Clarity Sharpen. Now, since we stretched the stars in, the sharpening, the stellar sharpening may be a little bit too much for your liking, but I'm going to use them both just to show you. So I'm going to select the both options, so it'll do the stars and the galaxy, clear my input directory, and I'm just going to leave the stellar and non-stellar amounts to their default settings and click apply. This will take a few minutes, so we'll come right back when it's finished. All right, the sharpening's done, so let's just zoom in here a little bit, and we'll do an undo and then a redo. And it looks good. They're not too over sharpened, I suppose, but preference again, right? So now I want to denoise the image. So, well, actually, let's zoom back up in here so we can actually see it working. And again, we're going to use a new script in Siril under Python scripts, which is Cosmic Clarity Denoise. We're a color image, so I'm going to select full. We're going to clear the input directory and then just click apply at the default settings. And once again, this will take a minute, so we'll be right back. All right, denoising is completed, so we'll close the script and we can do a before and after, and we have a nice clean image now. Back up a little bit and just, I mean, look at all the HA in there. That stuff, the way it popped because of this whole continuum subtraction, I'm very happy with the end results. And then what I like to do sometimes as a final step is add a little bit more depth into the object. And if we come up to image processing and under filters, contrast limited adaptive histogram equalization. That's a mouthful, right? But it's a pretty cool tool. I mean, default, you can change your tile grid size here, but already it feels like it gave it more depth. It's more contrasty. If I untick preview so we can see the before and the after, and I know it's a preference thing, you can play with the grid size as well to give it a little bit different effect. But, you know, use it if you want. Otherwise, don't. It's fine. I'm going to leave it at the grid size at 8. I like that. Click apply. And that's it. We're done. I'm going to come over and save this off as M31 final. And then that's it. I could also save it as a JPEG so I could post it on social media, what have you. You guys know how to do that. But let's go back and take a look at that second option that I was showing you in the script for continuum subtraction. So we're going to, once again, open up just our HA image, and we'll come into an auto stretch view again. And then scripts, Python scripts, run continuum subtraction again. And we'll look at using the continuum subtracted narrowband. Just like we did last time, we need to add our continuum image, which is our red channel. Leave it at auto for now. I'm going to untick the plot since we already went over that. And just a reminder, the enhancement factor only applies if we're using the enhanced continuum option. So this has no effect on what we're doing right now. So just like last time, I'll run it without creating that selection just to show you what kind of a result that you can end up with. So we're all set. We're just going to hit apply. And that actually looks really good. But again, to get the optimal result, we really want to do this with a selection. So I'm going to draw a selection around the galaxy, just like we did last time. And then back up in the script, we'll do auto, and then click apply. Like I mentioned before, it allows it to run faster and you'll get a better result most of the time. In this case, this isn't ideal. Letting it compute the entire image actually gave us a better result. So I wanted to show you this because it's going to be different for every set of data, right? This little black area in the core of the galaxy, I'm not crazy about. We really don't want to see that. So what you can do, you can either play with these numbers, your subtraction number, and make adjustments there, or you can try a different selection. So instead of selecting the entire galaxy, if I was to just grab like the right side of it possibly, and then come back and set our factor back to auto and then hit apply, you can see that's the result that we're looking for, right? The core isn't blacked out like it was before. That's a good image for us to be using for our HA. Like I said, you can play with the subtraction factor as well. So if we put this back in there and draw a selection around there just to get back to where we saw that black core. Yeah, so the other way of doing it is you can just mess with the numbers. So we're at 0.3034. If I was to set this to say 0.25, and again, we'll grab my selection and run it, it cleared that out for us. That may actually be a little bit too much, but you get the idea. So we can go maybe 0.28. So you can do it either way. You can play with your subtraction factor to get rid of any black areas that may still be appearing, or you can try different selections in and around the object that you know contains the HA emission that we're trying to enhance in our final composite. So we're good with that. We'll hit close. Just like before, we're going to have to save this. So I am just going to call this one CS for continuum subtraction, 32-bit, save anyways. And now we're ready to create the composite in Pixel Math. So we're going to come up to image processing and then Pixel Math. We're going to hit our plus button because we need to add our files. So we need our red, green, blue, and our continuum subtraction image, just those four. Click open. We're going to untick use single RGBK, and I have some presets for the formulas set down here. I'll leave them in the description as well. But for our red channel, we're going to use this formula. And I accidentally hit my enter key, so that's why we're seeing syntax error because we're not done yet. For our green channel, we're going to enter green, and then our blue channel is going to be this formula here. And then before we actually hit apply, we want to rename our variable for our HA to HACS. You can see HACS is in both of these formulas. One thing to keep in mind, the variable names are case sensitive. For example, I have a capital R here, which is used in both of the formulas. If I was to use a lowercase r here, it would look for a lowercase r variable and not find it and cause a syntax error. So just make sure you match your case. Last thing we need to do is add our parameter because there is a Q parameter in here. So we're going to set that to 3 because I know that works well. You can play with this number. With all that in place, just click apply and then close. And there's our final composite image. At this point, just go back and go through all the processing that we just ran through like we did when we did the enhanced continuum. Everything still applies. Do your crop, your background extraction, your stretching, and you'll be good to go. So another great script from the developers over at Siril, right? This one saves us a little bit of time, helps automate things. We all like easier processes sometimes, right? So let me know what you think in the comments. I want to say thanks to all my members, both here on YouTube and on buymeacoffee.com. I also have a Discord server now. Links for everything are down in the description if you want to come over there and start some conversations. As always, I appreciate everybody's time. If you haven't already subscribed, please consider subscribing. Like, share, comment on the videos. It all helps the channel grow. So that's a wrap for this one. We'll see you on the next video, and clear skies.